Section 5.6 is the last section in Chapter 5. We're graphing inequalities with two variables. So because we have two variables, we now have two axes. You know, before we had like x plus 3 is less than 2. Notice there's only one variable here, and when you graph, you only had one axis. So you'd subtract the 1, this would be negative 1, open circle, and it's less. So that's what we did before. There's only one variable, so we only have one axis. Now we have two variables, so we're graphing like this. We're finding ordered pairs here. If you have trouble graphing, it might not be a bad idea to look back at section 3.1. We did some graphing in that section, so it might not be a bad idea to look back to that video and look back to those notes if you still have them. Look back in the book there. But there's two changes that are different when we have inequalities like this. So think of it as 3x minus y, if I can write here, minus y equals 2. Think of it like this. Well, how do we solve this equation? We got to find ordered pairs, so you can make a table. That's option 1. Make a table. So if x is 1, we put 1 in. So 3 times 1 minus y equals 2. 3 minus y equals 2. 3 minus 1 is 2. So 1, 1 is a point. And then pick another value. 2. 3 times 2 minus something is equal to 2. So 6 minus 4. And you do 3. And 3 minus 9 minus what is 2? 9 minus 7. And then you plot these points. So we have 1, 1, 2, 1, 2, 3, 4, 3, 5, 6, 7. So there's our points for our graph. Now, it isn't equal to, so it's not a line. It is a line, but it's not a line like what you're used to. This less than tells us two things. Because it's not equal to, it's a dotted line. And now we have to shade somewhere. So, if you have less than or greater than, it's a dotted line. If it's equal to, it's a solid line. And then we have to shade too. So to shade is you pick a point, test a point, and if it's true, that's where you shade. If it's not, that's not where you shade. So let's pick, it's easiest to pick 0, 0 and plug it in. 3 times 0 minus 0 is less than 2. Is 3, because, oh, that's 0, sorry. 0 minus 0 is 0. Is 0 less than 2? This is true. So we shade where that point is. We're going to shade all of this. So that's one way. Go make a table. In example 2, we're going to look at finding the x and y intercepts. So there's just different ways to graph. You can choose your favorite option. If you want to make a table for every single one, make a table for every single one. If you want to find the x and y intercepts, do that. If you have a better way, do that. But we're just graphing. So again, think of it as x plus y equals 10. Now we're looking for when x is 0 and when y is 0. When x is 0, that's the y-intercept, so plug it in. 0 plus 5y equals 10. Well, 5 times what is 10? 5 times 2. So 0, 1, 2. And then now we put 0 in for y. X plus 5 times 0 equals 10. That goes away. X is 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know my graph is bad, but I wanted to squeeze it in there. Now you have to ask yourself, is this line solid or dotted? Well, if we look back up here, if we don't have the equal sign, it's dotted. If we do, it's solid. We do. So There's your line. Now we have to shade. So in order to shade, we pick a point. You can pick any point you want. I choose 0, 0 because it's easiest, and plug it back into the equation. So 0 plus 5 times 0 is less than or equal to 10. That'll go away. So 0 is less than or equal to 10. Is that true or false? So we shade where that point is. If it's false, if this is not true, then we would shade on the opposite side. Let's go on to one more on the back. Hopefully this will kind of help where the shading with us or whatever. So graph this. Think of it as y equals x plus 3. Well, you could make a table, but we also have the y-intercept and the slope. So b is 3 and m is 1. So we start up 3, 1, 2, 3, and put a dot. And our slope is 1, so up 1 over 1, up 1 over 1. And then we look back. Is this a solid or dotted? Well, it's a dotted line. And then we have to test. I'm going to test 0, 0 again because it doesn't go through that point. 0 is bigger than 0 plus 3. Is 0 bigger than 3? False. So then you ask yourself, which side do I shade? Do I shade down here where this is false? Or do I shade up here where that's true? Shade up here where it would be true. Because it's false down there. We can't shade down there. We got to shade on the opposite side. So that would be graphing example 3. But now it says which ordered pairs are in the solution. Here you're just taking these numbers and plugging them in. So we already tested 0, 0. 0, 0 is false. So that's not part of the solution. Plug in 8 is bigger than or equal to 1 plus 3. Is 8 bigger than 4? Yes. So that's part of the solution. Plug in 2, 0. 0 is bigger than 2 plus 3. Is 0 bigger than 5? No. Plug in 4, negative 1. 4 is bigger than or equal to negative 1 plus 3. Is 4 bigger than 2? Yes. So you're just testing these points, plugging them in the original equation. And if it's true, they are part of the solution. If it's false, it's not.